So you all have heard about the Raspberry Pi and how I want to introduce it as part of the curriculum for the fourth quarter. And just to give you guys a clear impression of what it entails, on Wednesday, tomorrow, a guy's going to come in whose name is Cisco, and he's going to give you all a demonstration on what the Raspberry Pi is, its history, how it's being used, and the things that you could possibly do with it. So you'll go ahead and go through that tomorrow and experience what it exactly is. And then the following day, on Thursday, I'm going to give you all a survey asking you if you would like to pursue it for the fourth quarter of the year, or if you would rather continue with the Pygame curriculum. And so I want to go either way. Like, there's reasons why I want to go with the Pygame, and there's reasons why I personally want to go with the Raspberry Pi. And here are just an overview of some of the advantages and disadvantages. And so first of all, we have the Pygame curriculum, which is going to take us in the fourth quarter. And basically, in the fourth quarter, what I have planned is that we're going to build a game called Density, and we're also going to build a Raiden clone. Raiden is a top-down shooter, kind of like I don't know what, like 1942, right? I'm not sure if you've played that game before. And some of the advantages of using the Pygame curriculum is we'll gain a firm understanding of object-oriented programming, because we'll build these two games, which will allow us to exercise that muscle, right? I'm going to build them both under we're going to build them both under the object-oriented programming model. And so that will help prepare us for AP Computer Science when that comes around. And also it helps to build a mental model of the gaming framework, game design framework, because all games follow the same framework where you have a while loop, and in that while loop you have certain things happening. And so it's kind of different from just programming procedurally in the traditional sense, what we've been doing for the first half of the year. And it's nice to get familiar with that if you wanted to make any games, right? And that's like, you use the same framework in every area of game design, from JavaScript games online to games on mobile devices to video games that are built in high-end gaming, factories, right? Like I don't know, I guess, like, what was the one that made StarCraft? I forgot what their name was. But anyhow, here, and another advantage would be to continue the curricular pathway that we have been traveling on over the first 3 semesters, or I'm sorry, 3 quarters is what it should read, in the Intro to Python course. And then some of the disadvantages of the Pygame curriculum is that it can be quite challenging. And so, if you're a little bit shaky on how we're going so far, well, then once we get into the Pygame curriculum, like really into it, it might be a little bit more than you can chew. Hopefully I'm trying to pull it off in a way that's easily digestible, but it might be a little difficult for some of you. And so here, the second one is that as the projects increase in size, then a lot of time is going to be spent on debugging, and debugging is probably like the most frustrating and also most rewarding part of exercising computer science. So that's an advantage and a disadvantage. And then the last one is, if you're not interested in game design, then it could be seen as tedious, right? You're doing all this work just to get the bullet to fly in the right direction, and after a week and a half, you finally get it to fly towards the ship, and it's like, oh yes, I finally got it. But if you're not interested in game design, then you might be like, dude, this is too much work for such little reward, right? So that's the Pygame curriculum. That's what we're going to be doing. And then the Raspberry Pi curriculum, well, we're going to create IoT devices, and that stands for Internet of Things. And so when Cisco comes in, he's going to explain that idea a little bit more. And what it basically is to create a device that you can control over the internet wirelessly, right? So if you have a device that detects if your dog came home in your house, you can see if that happens using a website from school, right? So that's like an Internet of Things kind of a device. And so we're also going to use and incorporate various sensors to create real-world situations. So I don't know, I guess for me to take, for instance, one example would be me taking roll, right? If we had a certain device underneath every single chair that sensed the amount of body heat coming off of the chair, then I wouldn't even need to take roll, right? I could just program each seat to a student's name, and roll could be taken automatically, right? That would be a real-world solution that can be created using the Raspberry Pi and a set of sensors. Right? And so here we go. Here are some advantages. We'll be able to build real-world applications using the CS concepts that we've gone over in class, right? So that's always exciting. Another one is to get a taste of electrical engineering to see if that's something that excites you, something that makes you, I don't know, passionate about your educational experience going into college. And also you get to see where electrical engineering overlaps with computer science, right? So you're going to be doing both sides of the coin when we build Raspberry Pi devices. Another one advantage would be you'd be able to design and prototype a solution to a real-world problem, right? Like I kind of mentioned about the classroom and taking role, so something along those lines. Another one here is, generally speaking, building the Pi project will be more fun, right? So I don't know. The way I see it is, you guys would all come into class. You'd all have your devices and wires and sensors, and you'd be putting them together, and you'd be connecting it to your Apple computers, and you would be testing your projects, right? So I kind of see it as being a more fun experience, even for those who kind of find the more abstract aspects of programming challenging. And so there you go. And here we have some disadvantages of the Raspberry Pi curriculum. One is that it deviates a bit from the trajectory that we've been going along for the first 3 semesters. Right, so the first semester is introductory, ideas and concepts, and then the second semester a little bit more of that. Third semester we're getting to Pygame and building a game using object-oriented programming. Well, the fourth semester should obviously be building more complex games using the object-oriented programming model. But we're going to be taking a left turn, and we'll work on building IoT devices using the Raspberry Pi. So it's a bit of deviation. And then we have here, will involve a significant amount of time actually building your device. So, I mean, in my mind's eye, this is an intro to programming class, right? Intro to coding class. So you should be spending 100% of your time here programming, right? Or designing, or solving problems using the Python programming language. But when we do the Raspberry Pi curriculum, a lot of your time, I would say probably like 40% of your time will be spent, connecting wires together, connecting to the computer, debugging why your sensor's not reading in the right information. So things along those lines, and not so much time is going to be spent, or not 100% of your time is going to be spent programming, in Python. So that's that. Next one is, generally speaking, the application of computer science concepts will be less of a focus, right, than it would be if we continued with our gaming design curriculum. Meaning that object-oriented programming won't be as thoroughly explored if we did the Raspberry Pi curriculum than it would be if we did the gaming curriculum. Okay. And then the last disadvantage of the Raspberry Pi curriculum would be that students would need to pay out of their pocket to buy the Pi and the set of sensors that they're going to use. And so the number that Cisco gave me was between $75 to $100 per student. The number I'm giving you all is probably about $100 to $150, right? So you always want to kind of give yourself a little bit more leeway. And so, depending on exactly what device you want to build, this number might change. So I guess we could say anywhere between $75 to $200, right? Depending on what you would want to build. And I believe we will have a class set of devices, but we won't have many, right? So if you use one of the class sets, you wouldn't be able to take it home and work on it, and you wouldn't be able to take it home at the end of the year after you've completed building your project. So I would expect most of you to pay and buy one yourself so that we can work on it. And so those are the advantages, disadvantages, and the general overview of the Raspberry Pi versus the Pygame. Again, tomorrow we will experience the Pi, and you'll get to ask Cisco any questions that you have. And then the next following day on Thursday, survey. And depending on your answers on the survey, we'll either go with the Pi or we'll go with Pygame.